Ampere's Circuital law. Ampere's Circuital law relates the integrated magnetic field around a closed loop to the electric current passing through the loop. It states that the line integral of the magnetic field B along any closed path is equal to mu naught times the net current I passing through the area bounded by the path. It is mathematically represented by close integral of B dot dl is equal to mu naught I. It provides a simple method for calculating the magnetic fields of current configurations which has high symmetry. Magnetic field due to an infinitely long current carrying wire. We have to calculate the magnetic field at a distance r from the wire. By symmetry, the magnitude of the field B is the same at all points of the loop, and its direction at a point is along the tangent to the circle at the point. The line integral of the magnetic field B around the circular loop is given by product B and 2 pi r. Also, by Ampere's Circuital law, closed integral of B dot dl is equal to mu naught I. From above two equations, we get the result B is equal to mu naught I divided by 2 pi r. Example. Let's take an example on magnetic field due to a current-carrying conductor. A long straight conductor carries a current of 120 ampere. At what distance from the conductor is the magnetic field caused by the current equal to 0.8 into 10 raised to the power minus 4 Tesla? Let's see the solution. Here, the given values are I is equal to 120 ampere, B is equal to 0.8 into 10 raised to the power minus 4 Tesla, mu naught is equal to 4 pi into 10 raised to the power minus 7 SI units. We know that B is equal to mu naught I upon 2 pi A. By putting the values in the equation, we get the values of A is equal to 0.3 meters. Hence, at 0.3 meters from the conductor, the magnetic field caused by the current equal to 0.8 into 10 raised to the power minus 4 Tesla. Solenoid. A solenoid is a current-carrying wire wound around the surface of a right circular cylinder. To find the magnetic field inside a long solenoid, we consider a rectangular loop ABCD. The segment AB of length L is parallel to the axis of the solenoid. The integral for the rectangular path ABCD consists of 4 integrals, one for each segment. Closed integral of B dot dl is equal to integration from A to B of B dot dl plus integration from B to C of B dot dl plus integration from C to D of B dot dl plus integration from D to A of B dot dl. It gives close integral of B dot dl is equal to integration from A to B of B dot dl, which is equal to BL. According to Ampere's Circuital law, closed integral of B dot dl is equal to mu naught NIL, where N is the number of turns per unit length. From above two equations, we get the result B is equal to mu naught Ni.